Good morning, dear students. I am your physics professor Dr. Nagaraj, explaining quantum computation numerical problems. So I already explained the theory part of this quantum computation in my previous videos, about 10 to 12 videos I made, and I received a very good response from you people. And some of you were asking for the discussion of numericals also. So for the benefit of you people and in view of forthcoming VTU examinations, I decided to do numerical problems. I have selected about 15 problems covering entire module. So we will discuss one by one. And please feel free to contact me, and if you have any doubts or if you have any numerical problem apart from this, you can send it to me. I will share my email address in the description box. You can interact with me. So dear students, please like my videos and also share with your friends so that they also get the benefit of these videos. Okay, let us go with the first numerical problem. So here comes the first numerical problem. A linear operator x operates such that x ket 0 equals ket 1 and x ket 1 equals ket 0. Find the matrix representation of x. So I hope you know what is ket, what is brac, all these things. So without giving much explanation of ket 0 and ket 1, I start with the discussion. See, here is x. X is a 2 by 2 matrix. I construct one 2 by 2 matrix, x11, x12, x21, x22. These are the elements. So we have to find out x11, x12, x21, x22. And we also know ket 0 is equal to 1 0, and then ket 1 is equal to just I erase this. Ket 1 is equal to 0 1. Ket 1 is equal to 0 1. Now we have to find out x11, x12, x21, x22 values. First I take this condition, that is x0, x ket 0 is equal to ket 1. Substitute. For x I substitute x11, x12, x21, x22. Of course it is a 2 by 2 matrix into ket 0 is 1 0, so that is equal to ket 1 is equal to 0 1. I hope you know how to multiply this and how to simplify this. So multiply x11 and into 1 x11, okay, plus x12 into 0 0, first element is generated. Next x21 into 1 is x21, okay, plus x22 into 0 0, so that is the multiplication, is equal to 0 and 1. So now you just equate. So if you equate, x11 is equal to 0, x11 is equal to 0, x21 is equal to 1, so x21 is equal to 1. So we got two values. Now let us take this one, that is x ket 1 is equal to ket 0. Again same thing, x11, x12. If you want, you can pause the video and you can continue with this, x22 into ket 1 andre eno, it is nothing but 0 1, so that is equal to 1 0. Okay, so continue with the multiplication. x11 into 0 is 0, okay, plus x12 into 1 is x12, first element is generated. x21 into 0 0, plus x22 into 1 is x22. So this is a matrix multiplication, that is equal to 1 0. Okay, dear students, now equate x11 into 0, that is 0, plus x12, and this is 0 plus x22, okay, so that is equal to 1 and 0. Okay, so now equate x12 is equal to 1, x22 is equal to 0, so x12 is 1, x22 equals 0. So we have four elements, here 2, here 2. Therefore matrix X is equal to, see here is the matrix, substitute, that is x11 andre 0, x12 means 1, x12 means 1. Next x22 21 is 1, x21 is 1, and then 0. So I have generated this X matrix. So what I did, I took this x11 value, x21 value, and then x12 value, x22 value, all these I substituted in this X matrix, so I generated this. Okay, well, I just erase all these things. I will share this JPG file of this particular numericals section, so that you can refer this even for during the examination time also. Okay, well, well, let me proceed with the next numerical. Next numerical is given a equals 0 I minus I 0. Prove that a dagger is equal to a. Dear students, first of all, you must know how to find a dagger. How to find a dagger? Sir, it is by taking the complex conjugate and then transpose. So you take the complex conjugate of the given matrix and then transpose it, then it is going to become a dagger. A dagger is also called as Hermitian. Okay, first I take the complex conjugate, that is a star, that becomes 0 plus I. Wherever you have I, you change the sign. Minus I becomes plus I, plus I becomes minus I. So this is the complex conjugate of the given matrix. Next I transpose. Okay, transpose of the complex conjugate. What do you mean by transpose? Yes, we know that is m becomes n becomes m. That is rows becomes columns, columns becomes row. So here 0i is the first row, it becomes first column. Minus I0 is the second row, it becomes second column. Okay, so this is what I generated here. Please observe this carefully. Observe the given matrix carefully. So both are same. 0 is here, 0 is here. Minus I is here, minus I is here. I is here, I is here. So 0 is here, 0 is here. That is nothing but A only. So A Hermitian is nothing but A only. Dear students, do you know which matrix this is? Sir, this is nothing but Pauli's Y matrix, sir. Correct, you are correct. It is Pauli's Y matrix. So this is about numerical number 2. So I hope you are following. Let us move on to the next one. Show that matrix U is unitary. What do you mean by unitary? Property. When do we call a matrix as unitary? So only when the matrix is multiplied with its Hermitian, and if the product is equal to identity I, then the matrix is called unitary. So that is a definition. That is U dagger is equal to I. So first we have to find out U dagger and then multiply with U. Then if the product comes out to be I, then U is unitary. Otherwise it is not, it is unitary. Otherwise it is not unitary. So our first task is to find the Hermitian. How to find Hermitian? In the previous problem I explained. Okay, let us proceed. So I will rewrite U in this form. U is equal to, I take 1 by root 2 common factor. It is allowed 1 I minus I. Please check, dear students. So here this is I and this is minus I. So therefore I left with I minus I. Next I go for complex conjugate of this. 1 by root 2 remains as it is. 1 remains as it is. This I becomes minus I becomes plus I. Are you following? Yes, I hope you are following. Okay, next I take the transpose of this. So complex conjugate, afterwards you take the transpose, that is 1 by root 2. Now 1 minus I, 1 I. Okay, so this is the transpose. So first column is the first row, second column is the second row. Okay, I have this itself is a dagger, this itself is Hermitian. Okay, now you take the product of U and U Hermitian, that is 1 by root 2 of U. U is already available here. Okay, so please check. U is this one. This is U and this is U dagger. Now you multiply both. Okay, so when I do so, what I will get? Let us check. So first I write U, that is 1 I minus I, this is U, into U dagger. U dagger is available here, into 1 by root 2 into 1 minus I, 1 I. So this is U dagger. Well, I continue here. So U dagger is equal to 1 by 2, because it is 1 by root 2 into 1 by root 2. It is 1 by 2. Okay. Into, well, simplify 1 into 1, 1. Right. Next, plus 1 into 1, 1. See, you must be very strong in matrix multiplication. So, I hope you know all these things. Well, next I into minus I, okay, first element generated. Next second element 1 into minus I, it is minus I. Next 1 into plus I, it is plus I. Second row, first column, that is I into 1, I. Next minus I into 1, minus I. Next second row, second column, minus I square. Next minus I into I, again minus I square. So it is u dagger, that is equal to 1 by 2 into 1 plus 1, 2, minus I plus I cancel, so it is 0. Again I minus I cancel 0, minus I square is nothing but 1, plus again minus I square is nothing but 1. Okay, that is u dagger is equal to 1 by 2 into 2, 0, 0, 2. Well, that is u dagger is equal to 2, if you take inside, it becomes 1, 0, 0, 1. This is nothing but identity matrix. Therefore, U is unitary. So, when do we call a matrix as unitary? Only when it is multiplied with the Hermitian and gives the product as identity, then it is unitary. Yes, it is unitary now, because I first determined Hermitian, then I multiplied with U, so I got identity matrix as 1, 0, 0, 1. I hope you are following. Now let us proceed with the next question. The next question is, find the inner product of states ket1 and ket0 and draw the conclusion. Well, first, what is inner product? Before that, let me write the column matrix of 1. It is 0, 1, and column matrix of 0 ket, that is 1, 0. Well, what is inner product? Inner product is bracket of 1 and ket of 0. This is inner product. Inner product. Okay. Now we have to find out the bracket. How do you find the bracket of 1? You know, bracket of 1 is nothing but Hermitian of ket of 1. Okay, bracket of 1, bracket of the vector is equal to Hermitian of its ket. This I already explained in my regular videos. On that basis, first I can find out bracket 1. Bracket 1 is equal to Hermitian. Hermitian means first you write the complex conjugate and then take the transpose. I did 2 problems on Hermitian. By now, I hope you know how to find the Hermitian. So, find the complex and then transpose. Anyway, in the given in the given ket vectors, there are no complex numbers. Therefore, you need not have to write the conjugate. Simply transpose it, it will become the Hermitian. What I mean to say, column vector 0, 1, you write it as row vector 0, 1, it becomes Hermitian. It is nothing but bracket 1. Did you understand? Suppose if I ask you to find inner product of 0 and 1, then also you have to do like this only. Okay, anyway, I will continue with this. Okay, ket1 is now converted into bracket 1. The bracket 1 is here. Therefore, bracket 1 ket0, that is inner product, is equal to 0, 1, that is bracket 1, into ket0 is 1, 0. Okay, so that is equal to multiply 0 into 1, 0, plus 1 into 0, 0, that is equal to 0. That means inner product of 1 and 0 is 0. See, these ket1 and ket0 are the vectors and the members belonging to complex vector space. They are vectors, and inner product is nothing but a dot product of 2 vectors. It is also called a scalar product of 2 vectors. See, in case of normal scalar product which you studied in PUC, scalar product will give you just a number. It is a real number. But if the vector space is a complex vector space, finally you will get a complex number. Complex number is generated. Okay. Suppose if the product is equal to 0, then we say those 2 vectors are perpendicular to each other. Actually, when the vector product, scalar product is 0, you recall the scalar product formula. it is scalar product. Okay, let me write it as vector A dot vector B, it is called as dot product, is equal to AB cos theta. I think you know, ಇದನ್ನು ಓದಿದ್ದೀರಾ ನೀವು PUC ನಲ್ಲಿ. So if theta is equal to 90 degree, ಎರಡು ವೆಕ್ಟರ್ಗಳ ಮಧ್ಯೆ ಆಂಗಲ್ 90 degree ಇದ್ರೆ, see dear students, even if I use Kannada, I already explained it in English, so don't think that sir is explaining only in Kannada. ಆ ಥರ ಏನು ಅಂದ್ಕೋಬೇಡಿ, don't feel like that, okay? Then ಈ cos 90 is equal to 0, therefore A dot B equals 0. That means A is perpendicular to B ಅಂತ conclusion ಬರೀಬಹುದು. ಹಾಗೆ ket 1 is perpendicular to ket 0 ಅಂತ. ಈ ತರ perpendicular ಇರೋ ವೆಕ್ಟರ್ಸ್ ಅನ್ನ ನಾವು ಆರ್ಥೋಗೊನಲ್ ಅಂತ ಕರಿತೀವಿ. ಆರ್ಥೋಗೊನಲ್ ಅಂದ್ರೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಅಂತಂದ್ರೆ ಅರ್ಥ. ಸೊ ಡ್ರಾ ದಿ ಕನ್ಕ್ಲೂಷನ್ ಅಂದ್ರೆ ನೀವೇನು ಹೇಳಬೇಕು, ಅಕಾರ್ಡಿಂಗ್ ಟು ದಿಸ್ ರಿಸಲ್ಟ್ ket 1 and ket 0 are mutually perpendicular to each other ಅಂತ ಹೇಳಬೇಕು. Are you following? No? Yes, I think you follow this. This is not a very big issue. Okay. Well, we will move on to the next question. Next question is, given ket phi is equal to alpha 1 alpha 2, ket phi is equal to beta 1 beta 2. This is psi, you have to pronounce it as psi. This you have to pronounce it as pi. Okay. Phi, even sometimes you call it as phi also. Okay, because this Greek letters pronunciation is bit difficult. Well, you have to prove that brach phi psi phi is equal to inner product of phi psi is equal to complex conjugate of inner product of phi psi. Well, we know how to find the inner product. Consider, well, first I start with this one. Consider psi phi inner product, that is equal to brach psi, this alpha 1 alpha 2, I have to change alpha 1 alpha 2. I don't know whether alpha 1 is a real number or a complex number, so better I put the complex conjugate. Okay, so this is the Hermitian. Okay, actually I already told you in the previous slide, brach psi is always Hermitian of its ket. This is what I told. On that basis I am writing this particular part. Remaining ket psi, ket phi is equal to beta 1 beta 2. Okay, so I have taken only the first part of the given condition, this one. Okay, now let us proceed further. This is equal to multiply alpha 1 star beta 1 plus alpha 2 star beta 2. So this is my brach phi ket phi. Call this as equation number 1. Now you consider phi psi. Phi is in the brach state, that means I should write beta 1 beta 2 along with its complex conjugate, and psi no change, it is a column vector alpha 1 alpha 2. Are you following? No, I hope you are following. I don't think it is too much complicated numerical. It is more of mathematics than physics, right? So it is something like physics teacher teaching mathematics, don't you think so? Yeah. Okay, so that is equal to beta 1 star alpha 1 plus beta 2 star alpha 2. This is phi psi. Now I go for complex conjugate of this. That means beta 1 star alpha plus beta 2 star alpha 2, alpha 1 alpha 2. For that complex conjugate, ಅದಕ್ಕೆ complex conjugate ತಗೋಬೇಕು ನೀವು. So ಅವಾಗ ಏನಾಗುತ್ತೆ, what happens, see beta 1 complex conjugate of the complex conjugate becomes beta 1 only. Next alpha 1 star, beta 2 becomes beta 2, alpha 2 becomes alpha 2 star. So this is phi psi complex conjugate. Call this as equation number 2. Now check equation 1 and 2. From 1 and 2, look at the RHS of first one, that is equation 1. RHS of equation 1 is, just 1 minute, I change the color. See, this is RHS of equation 1 and this is the RHS of equation 2. I request you to observe them carefully. Beta 1 alpha 1 star alpha 1 star, alpha 2 star, beta 2 beta 2. Therefore we can say brach psi ket phi, that is inner product, is equal to phi psi complex conjugate. Hence, this is what we were supposed to prove. So we have proved it. Hence the proof. Okay. Hence the proof. So that's all about this numerical. This is slightly different numerical. You can expect this in the examination. Okay. So next, let us move on to the next question. I think I did this in a regular video session also, and it is there in my study material also. Find the inner product of ket u and ket v. Okay, dear students, it is inner product of ket u. So I have to change it to bra q. Bra q, how do you do that? Well, 3 plus I becomes 3 minus I. 4 minus I becomes 4 plus I, and then I transpose it. So that is nothing but Hermitian. So ket to bra, how do you go? By taking its Hermitian. I think this is my 4th time or 5th time I am telling this. Well, now you take bra u ket v, that is equal to 3 minus I 4 plus I multiplied by 3I 4. Solve it. That is 3 minus I into 3I plus 4 plus I into 4. That is equal to 3 3s are 9I minus 3I square plus 16 plus 4I. That is equal to 9 plus 4 13I plus 3 plus 16. You know why it is plus 3? Because I square is minus 1. Already minus 1 is there. So it is finally 16 plus 3 19 plus 13I. Look at this answer, dear students. Inner product of two vectors generated a complex number. This is what I told you just few minutes back. Okay, this is another problem. Let us move on to the next question. Find the inner product of A with itself. That means I shall find bra A ket A. This is what I need to find. See, whenever you do the inner product of same vector, you get just only a magnitude, no complex number, only a number. It is something like modulus of A square. Okay, so well, let us do that. Well, bra A into ket A is equal to A minus IB, that is bra A, into AIB, that is ket A, that is equal to A into A, first element, plus minus IB into IB, second element, that is A square plus B square. Shall I write it directly like this? Yes, sir, we can write, because minus I into plus I is minus I square. Minus I square, minus I into plus I minus I square. Minus I square is anyway minus into minus plus B square. So that's all. That means this is A square minus I square B square. That is nothing but A square plus B square. So with this I come to the last numerical. Find the norm of U. What is norm? It is nothing but magnitude only. You have to find out the inner product of the same vector. That's all. Instead of asking you to do the inner product of the same vector, instead of asking you to find the magnitude of the vector, they are asking you like this. Norm andru kuda same method ane follow ಮಾಡಬೇಕು ನೀವು. ಅರ್ಥ ಆಗ್ತಿದೆಯಲ್ವಾ? Okay, I hope you are following. Well, let us do that. Well, inner product of bra q and ket u is equal to, first element is 1 plus I into 2. Okay, so this is a vector, into 1 minus I and 2. So that is equal to 1 plus I into 1 minus I plus 2 into 2. So this is equal to 1 square minus I square, that is A minus B into A plus B, that is A square minus B square formula, plus 2 into 2, 4. That is 1 plus 1 plus 4, that is equal to 6. Look at this beauty of this problem. Finally, I ended with only numerical, no complex number. Even though there was complex number in my numerical, finally there is no complex number at all. Okay. So well, with this I conclude this video. I have covered about 8 problems from linear operators, matrix operators, that's all. So in my next video, I will come back to you with numerical problems on quantum gates, both single qubit gates as well as multi-qubit gates. Okay, so thank you. Please keep supporting me. I will try to give as much as possible from my side. Shortly I will start with the discussion of model question paper also. There are 2 sets of questions papers I will discuss immediately. Maybe within day or 2 I will share the model question paper videos also. Okay, I hope you will be there with me throughout my journey. Thank you very much.